So here's an expression for the gain and loss in day one. When's the profit and loss? 0. It's when the day one, and this was the equation we saw earlier, now written notationally rather than with the numerical values. And so what if the stock price at the end of the first day was equal to one of the two prices on our binomial lattice? In other words, this is the assumption whereby stock prices move by one standard deviation. We have the drift term of RH because delta is 0, little delta, the dividend rate is 0, and we have a plus or minus 1 standard deviation move. This is exactly what we would have in the binomial lattice, where in each step we move 1 standard deviation plus the drift. So then with our delta approximating the value, we can rewrite this expression that this profit and loss will be 0 when this equation is satisfied, namely when the change in the prices of the option are exactly equal to, here I've inserted the value for delta from the earlier module, and we have this calculation. So now the question is, when is this satisfied? Well, what we want to do is to use an approximation. Many of you are familiar with Taylor series of the exponential. And the first couple of terms of this Taylor series are that if I have an exponential e to something, it's approximately equal to 1 plus that exponent. There's an error term, of course, but this is a good approximation when h is small, and for our purposes we can assume h is small. It's 1 over 365. It's only one day. And if we implement that approximation, the P&L being 0 equation transforms to this, namely, when the change in the difference between the end of day call price and the beginning of day call price is approximately half the difference between the up and the down call prices on our binomial lattice. The plus factor corresponds to when C1 is equal to U, and the minus corresponds when C1 is equal to the CD value. So when is this equation satisfied? And the answer is yes, it is. It's satisfied because we have that the value of the call option is an expected present value of those prices. And in fact, P star is approximately half. That P star is approximately equal to a half, and I'll show that in just a minute. And because P star is about a half, C0 is approximately the average. It's the present value of the average, but it's approximately the average of CU and CD. So we see that this, by virtue of our pricing formula for C0, is going to be satisfied whether C1 is equal to CU or C1 is equal to CD. We're going to return to this analysis in a more formal way later, but the conclusion from this is that if stock prices move 1 standard deviation, plus or minus, in our model, that the market maker profit and loss is 0. So first of all, why is P star approximately a half? We'll just look at the calculation. Recall that P star was equal to e to the r minus delta h minus e to the r minus delta h minus a standard deviation, because this is the D term. And then in the denominator, we have u, which is e to the r minus delta h plus sigma square root of h, and then subtract the D term. Now we can cancel out the common r minus delta h term, and this becomes 1 minus e to the minus delta square root of h, and in the denominator it's e to the sigma square root of h minus e to the minus sigma square root of h. And if you use the approximation we just saw for the exponential, where we can approximate an exponential as 1 plus x, excuse me, the numerator becomes sigma square root of h, and the denominator becomes 2 sigma square root of h. So that's an approximation, and we see that this is then a half. So in our model, P star is approximately equal to half, And in fact, as h goes to 0, it gets closer and closer to a half, and that's the reason in our earlier analysis, because C0 is approximately the average of CU and CD with a present value by virtue of what P star is, we then have the conclusion we were looking for. And we can see here, here's this is a table from the book where in each day stock prices were moved plus or minus 1 standard deviation. So in the first day we have a plus 1 standard deviation. In the second day you see the prices went down 1 standard deviation, they went down 1 standard deviation. In the next day down again and then up. So that's the sequences of plus and minuses in this formula here for the stock price. And you can see that the daily profit for the market maker is virtually 0. Virtually 0. So the theme, and this is something we'll see again in more formality, that the market maker's P&L will always be 0 in a delta hedging situation when the stock price moves plus or minus 1 standard deviation.